This video covers the second half of video number 15 all the way to video 17 of the game engine development. Two major changes for everyone. The first is that in your MyGL window.h you are to change qtimer.h to qtimer.h. In the MyGL window.cpp, instead of using qdebug.h, you change it to qcord/qdebug.h. Remember in video number 6, we are supposed to copy this algorithm to produce our triangle. For most of you, running this works. If that's the case, then what you do is that you watch the second half of video 15 all the way to 17 and just follow all the instruction as is. For some, running this code generate an error and the program crashes and we had to modify it. For us, we're going to do things a bit different, and the differences is this. In our MyGL window.cpp file, the same would be std.math, namespace say the same. Just copy the code as is from the video. In the initialize GL, you can delete MyGL list or GL in list, delete it or comment it out. I commented out. From paint GL, from video 17, we had this line of code. Delete that line of code or comment it out. In our for statement, within it, we change verts I equal verts I plus ship position. For the GL call list, we're going to delete that line of code. Underneath GL call list, you will type this out. This 3 lines of OpenGL statement or code or command is the same as this. So you can either copy and paste, copy this and paste it here, or just type it out. Within the my update, this stays the same. Nothing changed. For this line right here, it's just in case you have forgotten or you missed the earlier video. This line of code is for the user who runs this code, who runs this program, and the program lags the whole computer. So this is just to help them out. When you compile, the code, let it compile. It's slow. And run it, you should have a moving triangle like so. Now you may be wondering, this new modified code has 3 lines of OpenGL, while the original algorithm has 1, 2, 3, 4, 5, 6, 7, 8 GL command. And you might be wondering, since this is 3, why don't we just use this, because there's less command or less function call. There's a big difference. If you were to pick either using 3 commands or 7, you want to pick the 7. The major difference has to do with memory performance. GL gen buffer, GL bind buffer, buffer data, Vertex attributes, and buffer sub and draw array has to do with VBO, or Vertex buffer object. And what that does is that instead of using system memory to store your data, those 7 lines of code or commands place your data onto your graphic hardware itself. If you were to think about bandwidth, meaning transferring data from system memory to your graphic hardware, in terms of that, using VBO makes the bandwidth 0, meaning there's no bandwidth at all, and that's pretty quick. But here, GL enable client vertex pointer and GL draw array creates an array of data onto your system memory and then ship it to your graphic hardware. You might think it's slow, but it is still fast. It is a lot faster from doing the old way of things, which is drawing a primitive using GL begin and GL end. Real quick, I will go over exactly what this do. This GL vertex pointer, what it does, it tells OpenGL that you are going to generate an array of data. The number 2 represents how many coordinates per vertex. Our vertices data contains 2 coordinates, x and y, per vertex. So that's why we have 2 here. GL float let OpenGL know that our data type is a float. The 0 means we're going to start at index 0, and verts, it's our array, the array that will contain the data for OpenGL to use. The difference between using GL begin and GL end and using GL vertex array is this. Here is a good analogy. Let's say the United States or the East Coast is the client server, or the client side, which is the system memory, and the cruise ship is our bandwidth or the system bus. Europe would be our graphic hardware. With using this GL begin, each time a GL vertex is called, the data or a client is load onto your cruise ship and it gets shipped off to Europe, and you drop the client off. Then the cruise ship come back and it loads the second customer, and the customer gets sent out to Europe, unload, and the cruise ship comes back. And when the cruise ship back, finally the last customer get loads onto the cruise ship, get sent to Europe, unload, and come back. While this right here, what this does, it tells what you do is that you load the cruise ship with as much customer as you can. You fill it up. Once it's filled, you send it to Europe, then unload the customer and back. So when you use GL begin, you load customer, send them off, come back, load the customer, send them off, come back, load the customer, send them off, come back. And once this is reached, then your graphic hardware will calculate, does this thing to produce the triangle on screen. This, you load the cruise ship with as much data as you can to fill it up as much as you can. Then you send it off to Europe. Once it's sent off Europe, when you draw it, you use the GL draw array. Once this command is run, then your graphic hardware does this thing to produce the triangle onto the screen. So that is the difference. This is the slow way of doing things, the slowest way of doing things. This is a little quicker, and this, using VBO, is the fastest way of doing things. So for now, continue to use this, and I will continue to find a solution to our problem so that we can use Vertex buffer object as the old algorithm. And if you run this, it should work. Now let's go back. For the rest of video number 15 all the way to 17, just follow along because Jamie touched up on many important concepts and ideas that will help you out later on. And we'll return back from video 18. Until then, happy coding. I almost forgot. In our code, in our shift position, you notice it's 0.0, 0.0. In video 17 near the end, we change it to -1.0, -1.0. If we are to do that in our code, there's a chance you might have a runtime error, meaning for some it'll work that you'll see a triangle from the lower screen goes all the way to the top, but other, your program will load like so, will load, but you won't see no triangle. The reason why is that somehow between here and here, the vertex data would jump into the hundreds, continue on into the thousand, and because the coordinates it's in the hundreds and the thousands, which is above the one unit, 1 1 1 -1 -1 boundary, you won't see the triangle. I haven't found out a solution to that. So if that happened to you, don't use -1, just use 0, and it should work fine. And that is it. Into the next video. Happy coding.